In 5.2, we're going to be talking about ratio tables, and by the end of this section, you should have a pretty good answer to the question, how can you find two ratios that describe the same relationship? So jot that one down, and we'll try to check in on this question at the end of the section and practice problems. Two ratios that describe the same relationship are called equivalent ratios, and we remember the word equivalent usually means equal, so we're looking for two sets of ratios that would be equal to each other. And a lot of this is going to feel like some of the work we've done with fractions before, but there are a couple of ways that you can actually find equivalent ratios. One way is by adding or subtracting quantities in equivalent ratios, and then the other way is by multiplying or dividing each quantity in a ratio by the same number, and we're going to practice a little bit of each in this video. You can find and organize equivalent ratios in a ratio table. That's going to be what we use in this particular section. So make sure you remember to draw out all of the tables and label them carefully and fill them in, because that's the practice that we need for this section. In example 1, we're going to be completing ratio tables, and the directions tell us to find the missing values in each ratio table, then write the equivalent ratios. So in the last section we were talking about, interpreting ratios, and this one says for every 1 pen there are 3 pencils, and then we've got some numbers that are filled in, and then we're going to find these missing numbers right here. So we need to find the relationship between some of these quantities. So between 1 and 2 we could try adding another 1, and so if we add 1 up here, that would mean that the next one in the missing relationship there would be 3. So it means in this case we would have, for 1 pen there are 3 pencils. But then you also have to pay attention to what we would do down here, and it's a little trickier down here because we don't know what goes in the middle here, but if we are trying to figure out what we would get to do from 3 to 9, and we're going to add something in the middle, then you could think, well, if I count by 3s, it would be adding 3 here would give me 6, and I have to be able to add the exact same amount here, and that would give me 9. So sometimes it's going to feel a little bit like guess and check, but pretty soon we'll have a little bit more of a certain way that you can find things without having to guess so much. But in this case, you just go back and double check, did I do the same thing? So I added 1 to get to 2, and then I added 1 to get from 2 to 3, so those are equal up on top to each other, and then I added 3 to get to 6 and added 3 more to get to 9. So as long as you do the same thing on top in the same amount and then do the same thing on bottom in the same amount, it should work. Now the second part of the directions here said then write the equivalent ratios. So what that means is the first ratio was 1 to 3, so I'm going to write that. You can use word form if you want. The second ratio was 2 to 6, and the third ratio was 3 to 9, and so that's how we just write those equivalent ratios. In letter A, we were finding those equivalent ratios by adding, and we're going to try something different in letter B. One of the things that we wrote down at the beginning of the section was that you can also find equivalent ratios by multiplying or dividing by equal amounts. And so when we compare dogs to cats here, the original ratio they give us is for every 4 dogs there are 6 cats. And if I want to try using multiplication, then I have to figure out how I would get from 6 to 12, and I know that I would multiply by 2 to do that, and so then I would multiply by 2 up here, and 4 times 2 would give me 8, so I can use that as an equivalent ratio, and then I can look from 8 compared to 12 to this next set here, and I can get to from 8 to 24 if I multiply by 3, so then I would have to do the same thing down here, and 12 times 3 would give me 36. Okay, so I can do equivalent ratios that way. The next thing I want you to know about, though, is going to be that a lot of times as you get practice with this, I encourage you to always go back to that original ratio when you're making a jump anywhere past this first set. So we could do, multiply this first set by 2 and then multiply that middle set by 3. and find this, but sometimes going from this middle piece, you can't always find as clear of a relationship as we did here. And so I always encourage people to go back to the original ratio and look for relationships here. So if I think about how to get from 4 to 24, then one way to do that, and I'm doing it in blue because I know it's a little hard to see, so hopefully you have more room on your paper. If I wanted to get from 4 to 24, I could do that by multiplying it by 6, and then I would just multiply that bottom number by 6 also, and 6 times 6 would give me 36. So you can see how that gives me the same ratio, but without having to use that middle step necessarily. So as we get going, that'll be something that you get the hang of more and more, but I always encourage kids to go back to that original one when they get the opportunity to. As you're working through these on your own problems, make sure you draw out the two tables, and don't forget that after you fill in the missing values in your ratio table, here and here and here and here, that you also remember to take that final step of writing the equivalent ratios underneath, just like we did in example 1. For example 2, we're going to make a ratio table to help us answer this question. The question says that you are making sugar water for your hummingbird feeder, and a website indicates to use 4 parts of water for every 1 part of sugar, and then they tell us that you're going to plan to use 20 cups of water in your bird feeder, and we're going to try to figure out how much sugar you would need then to keep your ratios equal. So we're going to be creating that ratio table, and we're going to compare water, and when possible, try to include labels, and then we're going to compare that to the amount of sugar that needs to go into the mixture, and that was also in cups in the original question. And just like we did for example 1, you can try using addition repeatedly, or you can use multiplication to fill things out. And in this case, they told us the original ratio was 4 to 1, 4 parts water to 1 part sugar, and we're trying to get to 20 parts of water, or 20 cups of water, because that's what they tell us in the problem here. And so one way I know to get from 4 to 20 is to multiply by 5. And I do have to keep things equal because that's what equivalent means. So if I multiply that top amount by 5, then I've got to do the same to the bottom, which would give me 5. So this would mean that you need 5 cups of sugar in order to make the ratio correct for the hummingbird feeder. For this on your own, the what if is going off of that last hummingbird feeder example we just did. So when it says, what if you use 24 cups of water, you're sticking with that original ratio of water to sugar being 4 to 1. So you can just add on to that table that we just did, or you can create a new quick little table here, and then this time you're trying to find out what the amount of sugar you would need if you had 24 cups of water. So give that a try, and then you can check the answer in a minute.